Every point in this link will rotate except point O, because point O is said to be the axis or center of rotation. Yan yung kanyang center of rotation. Okay. Now, let us consider a point on this link, say point A, and let us observe its motion when it moves about point O. And so, of course, class, just like in a mechanical compass or drawing compass, this point A will describe a circular path, or it may be an arc if it will have a partial rotation. And obviously, for a full rotation, it will describe a perfect circle. Do you agree with me, class? Do you agree with me? Do you agree with me? Hello? Hello? Hello?
Yes, sir.
Bakit parang ang tamad yung sumagot? Ha? Nantok pa
Sir,
kayo?
hindi po.
Hindi. Kala
Naglag
pinantok.
kasi.
Sir, mahina po kasi signal, sir.
Mahina po kasi net, sir.
Mahina ang signal. Okay. Naku, yan, patay na tayo dyan. Kung yan ang problema. Mahina ang signal. Naku. Sana sa bahay na lang ako. Nasa school kasi ako eh.
Nasa school ka, sir?
Yeah. Bakit? Wala kayo sa school?
Wala, sir. Online class kami lahat today. 9 to 7 p.m.
Okay. So, nandito kasi ako sa school dahil may gagawin ako mamaya pagkatapos ng online ko eh. No? Sa research. Okay. Okay. Now, let's imagine that this slick has a partial rotation as shown in the drawing. Umiikot siya ng ganyan. So that this point A is said to have been displaced from A to A prime. And we call this displacement an angular displacement. Okay. So kung ito yung initial position 1 at ito yung kanyang final position at 2, we can say that as far as point A is concerned, point A is displaced angularly, and we call this class angular displacement. And usually, ang symbol natin sa angular displacement is a Greek letter called theta. So this is angular displacement. And it is expressed in terms of unit radian. Okay. Now, suppose ang initial displacement niya is yung theta sa buwan niya is 0. Okay. At ang final displacement niya, theta sub 2. Yan yung final displacement niya. Okay. We can say that the total displacement of this is the difference between the final and the initial. That's very basic. And suppose initial condition also states is time t1 is equal to 0. And yung final time niya is t sub 2. We can say that this total time of displacement would be t2 minus t1. Okay. t2 minus t1. So, yan ang sinasabi natin na angular displacement in terms of radian and time also in terms of second. So, notice class that it is convenient to use smaller units. Okay. like radian. And for time, we we use also a smaller unit, which is second. Since if we are dealing with smaller units, there's more accuracy in our computation. Our computation tends to be more accurate than when dealing with larger units. Have you noticed that plus kapag nagko-compute kayo, kung malilit na unit, mas, no, the percentage of error is smaller as when we deal with computations, as when we go with the computations using larger units. Okay. Now, the rotation or rotational motion can also be described in terms of angular speed or angular velocity. And we use class omega as a symbol for angular speed or angular velocity. Now, take note, class, that as I have mentioned before, speed is the scalar quantity of a velocity. And obviously, velocity class is a vector quantity. So when we say speed, it, it, it describes only the magnitude of how a body is traveling. But when we speak of velocity, it both describes the magnitude as well as the direction sense of the moving body. And in a sense, they have the same formula. Okay, but take note that speed is a scalar quantity while velocity is a vector quantity. So that's the difference between speed and velocity. But they have the same, technically they have the same formula. Okay. Now omega is another Greek letter. So okay, the next description of rotational motion is the speed at which it rotates, yung rate of rotation niya. So we call this omega. And omega is of course equal to the change in angular displacement divided by the change in time. So this is displacement rated with time. No? Now, if you're going to really come up with a common sense thinking, everything that moves constitute the involvement of time. Ibig sabihin, nobody can move without consideration of time because every motion is supposed to be rated with time. Okay. Do I make myself clear? Do I make
Yes,
myself
sir.
clear? Okay.
Yes,
So in
sir.
other words, everything in this universe is moving along space and time. No? So motion always involves space and time. Okay. Space and time. So kung time lang, walang walang involvement ang space, there is no motion at all. Kaya nga, inuulit ko yung sinabi ni Albert Einstein noon that, okay, ano yung sinabi niya? Nothing happens until something moves. Naniniwala ba kayo doon? Nothing happens until or unless something moves. We agree with that uh,
We agree po.
hypothesis of Albert Einstein. Okay, so everybody agrees to that because we know for a fact that okay, we are also a dynamic person. Everybody is considered to be a dynamic person. We constantly move, even when we sleep. Okay, even when we sleep. No? Okay. There is always a system in our body that moves. Okay. Unless you're dead, you will not move at all. No? Okay. So life should be dynamic. And death should be, of course, that is rest in peace. No? Okay. Now, another description of motion is the rate at which this motion will change, no, with respect to time. And we call this class angular acceleration. Have you ever hear the word angular acceleration? So, ang isang isusulat ko rito sa sketch ko is another description of motion which is alpha. And this alpha in here is called angular acceleration. Alpha. Now, siguro nagtataka kayo kung bakit most likely ang ginagamit natin ng symbols, especially the formulae, are Greek letters. It's because historically, in the ancient Greece, that country or that place was a center of education, center of scientific knowledge, center of political knowledge, no? Almost everything there, no? In that place, long time ago, no? When it was not yet occupied by the Romans, they have a very civilized and advanced society. Okay, and in the likes of Aristotle, no, uh, Aristotle. Aristotle. These are philosophers, and the Archimedes, who was a man ahead of his time. He was a man ahead of his time with many things in his mind. He was uh, a mathematician. He invented geometry. He discovered the law of buoyancy, and he made the first pump. No? Okay, used for irrigation. Siya ang unang gumawa ng screw pump. Well, it was a pump that was operated manually. No? It looks like a very, very long screw. No? Okay. Can be able to transfer water from bodies of water up to the upland farms. So yan ang Greece, no? They were considered to be the superpower, but then they were subdued by the Romans and became a colony of Rome, which was then it was included in the Roman Empire. So yan ang okay. But we can see that the influence of Greece is still alive today, no? Kaya nga itong mga Greek letter nila class, no, ginagamit pa rin natin sa engineering as symbols to represent a quantity. Okay, angular acceleration plus, we define this as we define this class as the change in angular velocity with respect to the change in time. Okay. Or to simply put, we now have this as omega all over t. And notice class that our unit in here for omega is radian per second divided by second, and that makes radian per second squared. Okay. So any question about the units class? Any question about the units? Okay. So tandaan niyo yan, ilang ano na yan? Theta, omega, and alpha. Okay. So let's move on to the next description of motion. Are you still listening, class? Are you still
Yes.
listening? Do you want to
Yes.
listen? Do you want to listen more?
Yes, sir.
Yes. Okay, very good. Sabihin nyo lang, kaya nyo na makinig, ayaw ko na rin magturo. Ano lang yun. Be honest. Kung ayaw nyo na makinig, ayaw ko na rin magturo. No? Okay. It would be senseless for me to lecture when nobody's listening. Di ba? Okay, next. So, makinig kayo, class. Because napakahirap ang online lecture. No? Because, I cannot read body languages here. No? It's really different compared to face-to-face. Sa face-to-face, nakikita ko yung mga body languages nyo kung naintindihan nyo yung sinasabi ko. Hindi. No? There is mass appreciation of interaction. Dito, class, hindi ko alam kung nandyan pa nga kayo no? I suppose na nandyan kayo palagi. No? Okay? Okay, class? No? Are you honest enough to really be religious in attending online classes? Okay, I hope so. Okay. Oh, meron pa ring late. Sino ito? Cyril, pagbibigyan kita ngayon, but next time, hindi na kita i-admit na. Okay. Sana.
Yes, sir.
Okay, so sana come early next time. Now, next description of motion. Don't worry, class, I will not take much of your time. No? Alam ko mahal ang load ngayon, no? I will not take much of your time. Don't worry. Okay. So please be patient with me because mahirap pag-drawing dito sa screen, sa whiteboard screen ko, no? Madulas. Okay, again. Referring to the same figure, but I'd like to sketch this again. Referring to the same figure. Yan. Ito yung point O natin, ito yung point A natin, and yan yung path ng point A. Yan. Okay. There is another description of motion pertaining to point A, which is tangential velocity. Tangential velocity. And we make use of the Greek letter nu, N-U. Oh, here's another latecomer. Okay, sino ba yung Abungan, Mr. Abungan, no? Okay, next time. Hindi na kita tatanggapin kung ganitong oras ka mag-i-in, no? Leonard?
Po, sir.
Next time, hindi na kita tatanggapin pag ganitong oras ka na mag-i-in.
Noted po, sir. Sorry po.
Okay. Sige. Okay, makinig ka na lang, ano? Kahit hindi mo na abutan yung first part of my lecture, no? Just like Cyril, magtanong na lang kay mamaya doon sa mga klase nyo kung ano yung unang na-lecture ko kanina. Yes?
Yes, sir.
Okay, sige. Ayan. So, sana yung lecture? Ayan. Sana yung lecture natin. Okay, nu. Bakit tinawag na tangential ito? Well, obviously because class, I should be very particular. This refers to the motion of point A alone. Okay. So let's have this as nu sub A to indicate that this is now the tangential velocity of point A. So as point A rotates about point O, there is another description of its motion which is called linear or tangential velocity. And I mentioned that it is linear, and indeed it is, because this V sub A, nu sub A, will describe a straight line in space. No? It would describe a straight line. Okay. You know, class, maybe uh, ganito na lang. Ano ba yung example ko rito? O ganito. Let's have a thought experiment. Halimbawa, uh, you are toying with this. Naglalaro kayo ng ganito, no? Dito sa point O, nandito yung kamay mo, hinahawakan mo yung point O. And then you tie a stone in here at one end of the string, and then you rotate this by an inward pull. Merong force na i-exert mo dyan para makapag-rotate ito. Okay. Ngayon, my question is, and you're going to use your imagination and also based on experiences, past experiences kung meron. Kung halimbawa, habang umiikit ito ay biglang naputol yung string. No? Biglang nakat. Saan pupunta yung stone na yan? Okay. Is it outward or is it in this manner? Which is which? Yung 1 or yung 2? Saan pupunta yung stone kapag biglang naputol yung string na yan?
2, sir.
2.
Sir.
Okay. So it will assume a straight path. Okay. Hindi pwede sa 1. At hindi talaga pwede mangyayari yan. No? Na sa 1 siya pupunta. Okay. No? Hindi pwede mangyari yan. So sa 2 siya pumunta. Yun ang tinutukoy ko na tangential or linear velocity. Now notice, class, that geometrically, nu sub A is tangent to the path of motion of A, and it is also perpendicular to the radius, which is the distance between O and A. So we call this radius R sub A. Okay. And these two quantities has a relationship, or it is related to omega. It is related to omega. Anong sabi natin sa omega? Angular speed or angular acceleration. In that, they are related with this formula. Nu sub A is equal to omega times R sub A. Okay, so another formula that has been derived here. No? Okay. And take note of the units involved. Okay. Our nu sub A, being a linear or tangential velocity, will have a unit in meters per second. Okay. Omega is in radian per second, and this is multiplied by meter for the unit of radius of the radius, and our final unit would be, of course, meters per second, as you can see. Okay. Now, sometime in the past, while I have this similar lecture with my students, somebody among the class have this kind of issue na, sir, paano ba naging meters per second yan? Saan napunta yung radian? Okay. Saan napunta yung radian? And of course, I don't have a ready answer for that question. No? I was caught flat-footed because pati ako hindi ko rin alam, no? So what I did was, okay, I I have my research. No, I have my library research, and I found out that radian has two properties. It can be treated as a unit. Likewise, it can also be treated as a ratio. And I'm going to explain to you, no, kung paano nangyari yun. Okay, so suppose here we have a circle. For purposes of clarification, we're going to explain the origin of the word radian. Okay. So kung meron tayong ganyang circle, yeah, the center of the circle, say at point O, okay, is a point that is equidistant, no, doon sa circumference ng circle. Okay. Now, if I'm going to draw a line emanating from point O, straight line, and then this line intersects a point on the circumference of the circle at point A, I will call this the radius of the circle. Now, this is how radian came to be. If I'm going to consider a distance, okay, AA prime measured along the circumference of the circle, and I call this arc S. Arc S. So AA prime is the distance in terms of arc length. Now, if I am going to stretch this arc, such that this arc is equal to R. Kung i-straighten ko yung S at ang measure niya is equal to R, then the ratio of this R to S or S to R is always equal to 1. So take note, class, what I mentioned here is a ratio. It is a ratio. And being a ratio, technically speaking, dapat wala siyang unit. But you know, class, past mathematicians gave a name for this, and they call this radian, or one radian. Okay, so yan ang isang property ng radian. Now, incidentally, the angle subtended by this arc, yung angle that is subtended by this arc, S, no, has an angle of 57.3 degrees. 57.3 degrees. Okay. And they made another description of radian, which is in terms of angular measurement. So that 1 radian became now 57.3 degrees. Okay. So this time, class, radian was treated as a unit. So kanina, ratio, ngayon naman ay unit. Are you with me, class? Are you with me?
Yes, sir.
Yes. Makinig kayo. Baka ibigay dito sa board exam. Nga kayo kapag hindi nyo alam nito, no? Okay, sorry for that. Umiinom ako ng kape, no? Now, so that dealing with this circle, and let's count kung ilang radian ang nasa isang circle. So we can have 1, 2, 3, 4, 5. Okay, 6. 5, 6 radian. At may sobra pa na 0.28. 0.28. Okay. Yeah. So we can say that there are all in all 6.28 radian, no, in one circle, or that is in terms of a cycle, that is one cycle, or we also call this one revolution. Okay. And take note, class, that this 6.28 is actually, class, also your 2 pi. So we can say that there are 2 pi regions for every one revolution. Okay, so take note of that, class. Uh, take note of this conversion uh, of region to revolution, and vice versa. No, vice versa. Okay. Now, rotational motion can sometimes be given in terms of RPM, or revolution per second. So kapag ganyan ang makikita niyong symbol sa rotational speed, this is actually expressed in revolution per minute, or this is rather known as RPM. No, RPM. Yan. Now, but in all the formulas mentioned above,